Hello my friends and welcome to this new practical tutorial, and mostly welcome to part 3, evaluating the model. We indeed now have our model that is trained, we even did some inference, but now a very important step in the whole machine learning pipeline or process is to evaluate the performance of your model. And in regression, the two most useful metrics, the most relevant ones, are R squared and adjusted R squared, and in this tutorial I'm going to show you how to get the R squared for our model and assess the performance. Alright, so let's do this. Let's create a new code cell here. And now, as usual, we're going to use the scikit-learn library to get this R squared metric efficiently. And so we're going to start with from sklearn, then dot, because once again we're going to access a new module now to get this R squared metric. But this time it's not going to be model selection or linear model. It's going to be metrics. Alright, metrics, here we go. So from the metrics module of the scikit-learn library, we are going to import, well, again, we're going to import a new function that is called R2_score. And this is exactly the function that will return to us the R squared of our model. Alright, so now, next step is to, of course, use this function. And so, because we're then going to compute the adjusted R squared, and the adjusted R squared is a function of the R squared, well, we're going to create a new variable now, which we will use later. We could directly return a value, but we're going to need the R squared variable here for the adjusted R squared. So, I'm going to create a new variable, which I'm going to call R2, and then this R2 variable is going to be what is returned by this R2_score function. So now, according to you, what do you think we have to input in the R2_score function? Well, you can see that here, but can you guess also? Well, in order to get the R squared, we need two elements, which are our predictions and the ground truth, the true values, the true energy outputs. And so we have that. We already have the variables for that, because indeed, the ground truth, the vector of true energy outputs is exactly y test, when we created the training set and test set at this step right here, right? We have y test here that contains the real, the true values of the energy output in a test set. And we also have now our vector of predictions ypred, which are the predicted energy outputs for the same data points of the test set. All right, and that's exactly, as you see, what we have to input here in the R2_score function. So let's do this. In R2 here, we're going to enter first y_test, that's the ground truth, the real energy outputs, and then y_pred, which are our predicted energy outputs. And based on these two variables, well, the R2_score function is going to return to us the R squared. And so let's do this. Everything is ready now. Let's run the cell. There you go. Then we're going to add a code cell here just to see what the R squared is. And play. And here is the R squared. 0.93, which is really good. But we saw that already. We expected a good R squared because when we compared our predictions to the ground truth, well, we saw that the predicted energy outputs were pretty close to the ground truth, the real energy outputs. Okay, so congratulations, you now know how to get the R squared using the R2_score function. And now in the last tutorial, we're going to compute the adjusted R squared. And actually, this time we're not going to use a function. We're going to directly compute it based on the formula. You know that the adjusted R squared is a formula using the R squared. So try to compute it yourself, and we'll do it together in the next tutorial. And until then, enjoy machine learning.